Hello algebra students, Mrs. Kim here, ready to talk about factoring out a GCF. First, I just want to make a quick note. If you're watching these straight from YouTube and not from the Play Pause It assignment on Canvas, then you might want to wait because we're going to be turning our notes in via Play Pause It as we move forward. So I just wanted to bring that up in case you caught these before and you didn't catch them from the Canvas assignment. So you might want to wait and go back to the Canvas assignment before you watch these notes because I'm going to collect them via Canvas and you're going to have some questions to answer as you watch. So let's get started. Today we are talking about what is a GCF and how is it found. There's going to be a lot of numbers today. If you have your multiplication chart out, or have your multiplication chart I gave you in class, you might want to get that out. If you have a calculator, you might want to get that. If you're not super fast with multiplication facts, it can be helpful. You can pull one up on your computer. A multiplication chart easy to find online as well. It can be easy to help us with that this unit. So what is factoring? If we look here, so what is factoring? Factoring is finding the numbers and variables that make up a product. So let me just change my color real quick here. So finding the numbers, that's a very light color, and let me move this over a little bit. Variables that make up a product. So a factor times a factor equals a product. We were doing factors last unit. We were factoring for radicals down to prime factorization, right? We did the factor tree and we found all the prime factors that made up a number. This unit, we're not going to be working on prime factorization, right? So if we look here at what it says here in our notes, it says, let's start with practice finding factors of numbers. As I mentioned, use your multiplication chart can be helpful. Remember, factors are numbers that you multiply together to get another number. For this practice, we will start with the number 1, which is always a factor. Then check 2, 3, 4, until we have all of the factors. Let's make a note here that we are not looking for prime factorization. So we're not going to be doing factor trees this unit. We're going to be just looking for all of the factors, whether they're prime or not. So we're not looking for prime factor. Move this over a little bit. Isation. We're not looking for prime factorization like in unit 4. All right, and if you ever have trouble reading some of my writing on here, I also upload my nicer, cleaner notes to Canvas as well. So afterwards, if you need to fill in any words that didn't make sense, you can always look at those as well. Or you can print those out ahead of time and follow along and then take your notes. But you should be writing and taking the notes with me. It's helpful to do it with me and then to look at the notes. All right, so factoring. So factors of 12. Here we are. Let's do this part together. So as I said, I like to start with 1 and go down the list. So I'm going to start with 1 and say, okay, 1 times 12 is 12, right? Those two things multiply together and give you 12. And then I'm going to check 2. And I say, okay, 2 times 6 gives me 12. And then I'm going to check 3. 3 times 4 gives me 12. And then once I hit a number here and then I've started going back up, I don't need to check any more numbers because I already had 4 on my list. And then 5's not going to work, 6 works, 7's not going to work, 8's not going to work because all those numbers are already on my list. So my factors here are 1, 2, 3, 4, 6, and 12. These are the factors of 12. They're all the things we can multiply together. Not prime factors, just factors. So we can multiply 1 times 12, 2 times 6, 3 times 4 to get 12. So these all represent factors of 12. All right, let's look at factors of 64. All right, so factors of 64 here. So I have 1 times 64, because 1 is always a factor. And then I say, okay, 2. 2 can go into factor 64. 2 times 32 is 64. And then I'm going to check 3. 3 is not a factor of 64. 3 does not evenly go into 64, so I could check 4. 4 times 16 is 64. I check 5. 5 does not go into 64 evenly, right? 5 is not a multiple of 64, so then I check 6. 6 is not a multiple of 64. If you have a multiplication chart, it's super easy to check these, or you can plug them in a calculator and check it. If your answer is a decimal answer, it's not a factor. Remember, factors have to go in evenly. So 5 does not work, 6 does not work, 7 does not work, but 8 does work. And actually, it's 8 times 8, right? Technically, it's 8 times 8 here. We only really need to list the factor once, right? So I'm going to make a note here. We only need to list once as a factor. All right, so if it shows up twice, we only have to list it one time. So my factors of 64 are 1, 2, 4, 8, 16, 32, and 64. All right, so those are my factors of 64. All right, so now I have two problems. Actually, here's 4 problems for you to do. So at this point in the notes, I would pause this and try to do these 4 problems on your own before you look at what I do, to see if you can start figuring out these factors. Remember, if you're not trying on your own and figuring out where you're stuck, then it's really hard to do math. So go ahead and pause this for a minute and see if you can get the factors of 48. Whoops. You want to get the factors of 48, of 70, of 16, and of 19. All right, welcome back. So hopefully you have factors for all 4 of those numbers. Let's go ahead and take a look at what I got. So for 48, I got 1 times 48, 2 times 24, 3 times 16, 4 times 12, 6 times 8. So I have 1, 2, 3, 4, 6, 8, 12, 16, 24, and 48. For 48, those are all the factors. For 70 over here, I have 1 times 70. I have 2 times 35. 3 does not go in, 4 does not go in, 5 times 14. 6 does not go in, 7 times 10, right? So 1, 2, 5, 7, 10, oops, 14, 35, and 70. So for those first 2, I gave you how many factors you were looking for. For 16 down here, I did not give you how many you're looking for. So you had to start thinking, kind of doing a little bit more outside the box. So 1 times 16, 2 times 8, 3 does not go into 16, 4 times 4. Once you get to a double, then you know you're done with your factors because you're already back up the other way. So 1, 2, 4, 8, and 16 are my factors of 16. And then factors of 19, I have 1 times 19. And are there any others? I do not think so. Those are the only 2 factors of 19, 1 and 19. So, right, 1 and 19. So down below here, I asked you, what is the one factor that every number above has in common? So this one factor that they all have in common is the number 1, right? Every single one of these has a factor of 1. Always. Everything can always be divided by 1, right? And so then we say we call numbers and expressions whose only factor is 1. Hopefully we all remember this from last unit. It's the same thing. It is prime, right? That's why we found those prime factors in last unit. So if you can only have factors of 1, then it is prime, right? 19 here is in fact a prime number, right? This is prime. All right. So now that we've looked at factors, let's take a look at finding the biggest factor. So going on to page 11. All right, so now let's review common factors. Right, if we have 2 or more terms, numbers or terms, then any factors that have the same, here we go, so we want the same, are called common factors. These factors can be both. Let me flip over here a little bit. So these can be numbers. All right, so these can be numbers and or variables, right? They can also be variables. So these can be numbers or variables. For all factoring in this unit, we will be looking to factor out the greatest common factor. Right? Greatest common factor is the biggest number or variable term they have in common. Right? We're taking out the greatest common factor first. We call this factoring out the GCF. So, actually, let's go here. Right? The GCF right here. You're going to hear me say that a lot in the coming sections. So the GCF is what we're factoring out. So we're going to practice listing all the common factors. Now I know as you move forward, you don't need to be listing all the common factors. In our notes, we're going to do it to make sure we understand how to find the common factors. But once you're moving forward and you're practicing on your own and doing your homework, you don't have to list all of the common factors if you found the GCF or if you found common factors. But they can be helpful to you to list them if you're stuck. So let's go ahead and start with listing them. So here we go. We have 20 and 48. We're going to try to find the GCF. So let's look at 20, right? And if we look at the factors of 20, we have 1 times 20. We have 2 times 10. 3 does not go in. We have 4 times 5. Here we are. So those are the factors of 20. Because now we're at 5, 6, 7, 8 don't work. 9 doesn't work, right? We're back up the other side. And then I look at 48. So I have 1 times 48. I have 2 times 24. I have 3 times 16. 4 times 12. And 6 times 8. I'm doing these fast, I know. Feel free to pause it if you need to catch up. So if you're still writing and I'm still talking, pause it. And then you can catch up. So here we go. So we got 1 times 20, 2 times 10, 4 times 5. We have 48. We have 1 times 48, 2 times 24, 3 times 16, 4 times 12, and 6 times 8. And what I'm going to do right now is I am going to find the common factors, right? So they have 1 in common, they're in both lists. Common factors are what they both have in common. They both have a 2. They both have a 4 on their list, right? They do not both have a 5. They do not both have a 10. They do not both have a 20, right? And all of these numbers they do not have. So the common factors are 1, 2, and 4. The greatest common factor is the biggest number on that list, which is 4. All right, so if you don't see what the greatest common factor is, list out all the factors and find the biggest one in both lists. That's all we're doing there. All right, so let's look at 24 and 45. Here we go. So let's look at the factors of 24. And as you'll start seeing a lot of these, you'll come across the same numbers. So if you have nice clean notes and written stuff, you can always go look back at old lists of numbers you have. All right, so you have 1 times 24, 2 times 12, 3 times 8, and 4 times 6. Those are the factors of 24. It has 8 total factors. And then we look at the factors of 45. And I have 1 times 45. 2 does not go in. 3 does though. 3 times 15. 4 does not go in. 5 goes in. 5 times 9. 6 does not go in. 7 does not go in. 8 does not go in. Then we're back to 9. It's already on our list. So here are my factors of 45. So now we're going to find the common factors. So I have 1 in common, right? Because they always have 1 in common. Do not have 2 in common, but they both have a 3 in common. Do not have a 4 in common, do not have a 6 in common, do not have an 8, 12, 24, right? None of those are in common. So the only 2 factors they have in common are 1 and 3. The GCF then is 3, because 3 is the biggest number. So 24 and 45 have a GCF of 3. Now, let's look at a problem that has variables in here, right? So I have 12x squared and 8x. So we're going to start with just the numbers, the coefficients. Remember the numbers out front are called coefficients. Let's start with those first. So we're going to do 12, factors of 12, which is 1 times 12, 2 times 6, 3 times 4, right? Those are the 6 factors of 12. And then we're going to do factors of 8. I have 1 times 8 and 2 times 4. And then we look for our common factors. So my common factors here, I have a 1 in common, I have a 2 in common, I have a 4 in common, right? So I have 1, 2, and 4. So those are my coefficient, my numbers out front. Now we need to look at the variables. right? So I have x, so my variables, I'm going to put VAR for variables. I have x squared and I have x. Right, so if we were going to list out x squared as factors, we would say it's x times x, correct? And then x is just x by itself. So if I'm looking for a common factor, they both have a single x in common. Right, they both have one x. The x squared has two of them, but but this guy down here only has one. So what they have in common is one single x. So if I'm looking over here for my GCF now, they're both going to have an x, and then they both have the highest number is the number 4. Right, so my GCF of 12x squared and 8x is 4x. Right, see that? So the coefficients out front is the 4. The variables, they both have a single x because this guy right here only has one x. That means you can only take one x out. You can't take out two of them. All right, let's look at the none over here to the right. All right, so this one, I like to always start with my coefficients. This one's kind of obvious, but let's just make sure it's clear to us. The coefficient on this x to the 4th is really a 1, right? Which is just 1 times 1. And the coefficient on this x squared is a 1, which is also just a 1 times 1. So if you're looking at the GCF here, right, it's just a 1. This is just the number 1. Or we can think of it as we don't think of it has a coefficient, but there is a 1 there, right? That's the one that we just don't usually write the 1. And then if I'm looking at my variables here, I have x to the 4th, which if you want to write them out, if it's helpful for you to look at them written out, on the next page I'll probably stop writing them out, but for here, let's write them out. Right, this is what we have here, this is what we have here. And so if we're looking here, what they have in common, do this in blue here, is they both have a single x in common, and then they both have another x in common, right? You can think of it this way, that they both have these two guys, right? They have x and they have x squared. This is what I boxed. So if we're looking for the GCF is going to be x squared. And then if you wanted to put that 1 out front, you could, right? Or we just write x squared usually. Usually we don't put that 1 out front. Right? So the GCF of x to the 4th and x squared is just x squared. All right, now you have 2 to do here. So go ahead and pause the video, find the GCF of 24 and 52, and then find the GCF of 36x to the 3rd and 48x squared. All right, so hopefully you paused the video and did this on your own and didn't just wait for me. So let's go ahead and take a look now. So here, my factors of 24 are 1 and 24, 2 and 12, 3 and 8, 4 and 6, right? Those are my factors. My factors of 52 are 1 and 52, are 2 and 26, and 4 and 13. So if I look at my GCFs here, we got 1s, we got 2s, we got 4s. So 1, 2, and 4. So my GCF is 4. My common factors are 1, 2, and 4. My GCF is 4. And then looking over here at 36x to the 3rd and 48x squared. Uh-oh, let me go move this over so we can see the work over here. All right, so we have 36 is 1 times 36, 2 times 18, 3 times 12, 4 times 9, and 6 times 6. For 48, I have 1 times 48, 2 times 24, 3 times 16, 4 times 12, and 6 times 8. Those should be all the factors you found. Then we have 1 and 1, we have 2 and 2, we have 3 and 3, we have 4 and 4, we have 6 and 6, we have 12 and 12. All right, so there's a lot of them here. So 1, 2, 3, 4, 6, and 12 are all the numbers. And then if I look at my variables over here, right, I had x to the 3rd, which is x times x times x, and I had x squared, which is x times x. So if I'm looking for, here they have an x in common, right? So that's an x. They have two x's in common, which means it's also an x squared. So my GCF, the biggest is x squared for the x's, and then the biggest for the number is 12. So 12x squared should be the GCF between 36x to the third and 48x squared. All right. As I told you, this is going to be a long, maybe I didn't mention it, but this is a longer unit of notes. I apologize, but got a lot to kind of cover here. So now we are going to talk about finding the GCF polynomials. All this factoring practice, and if we were in class together, we'd have been doing this practice together in class. Wouldn't necessarily been just straight up notes, but is trying to make sure we understand how to find a GCF. So this unit is all about polynomials. Now that we've reviewed how to factor, we are going to practice factoring out a GCF from a polynomial. Factoring out a GCF is the first. This is important. This whole rest of this unit. The first thing you need to do is look for GCFs. Always. Always, always. That's the next block over here, right? Is the first thing we must always check. So always check. For when factoring any polynomial. To do this, we will divide or factor, right? So this is factoring is really our division, right? We already added, subtracted, and multiplied polynomials last couple weeks. Now we're factoring or dividing out the biggest common number, right? So the biggest common factor, the greatest common factor is the number and or the amount of variables, right? Up above, we were finding the number and the letters for each of the terms. Right? So factoring out a GCF is the first thing we must always check for when factoring any polynomial. To do this, we will divide or factor out the biggest common number and or amount of variables. All right, so let's do this. On to page 12. Page 12 here, we now have some polynomials to factor. So let's see if we can put together what we just learned and do some factoring here. I will go over, so here's my polynomial, 3x3 minus 12x squared plus 15x, right? So you'll have this on your note guide, hopefully. So I'm going to scroll over here a little bit, and I gave us a place to write these common factors out. As I mentioned, as you move forward, you're not going to write them out. You're just going to, if you identify it or see it, that's great. If you pull out something and something not being the greatest, you can keep pulling out factors and make it the greatest. So don't worry about that. But let's go ahead and just use this system here that I was showing you. Right, so the common so we have 3, 12, and 15 are the coefficients of our polynomial. So the factors of 3 are 1 times 3. Factors of 12 are 1 times 12, 2 times 6, and 3 times 4. And factors of 15 are 1 and 15. 2 does not go in. 3 and 5. 4 does not go in, and that's it. So there's our factors. So if we're looking for the GCF, right, we're looking for the biggest. So they all have a 1. They always all have a 1. These guys all also have a 3, right? And we don't have to check anymore because 1 and 3 only has 1 and 3. So I know I have a GCF of 3. And then I look at my x's over here on the side, and I said, okay, I had an x to the power of 3, I had an x to the power of 2, and I had an x. So when I'm listing my variables, you have to list every single term. So I look here and say, okay, this was x times x times x. This is x times x, and that is just x by itself. So if we're looking for, this one has a 1, this one has 1, right? They all 1 here. The lowest number is the number that they all have in common. So 3x is what our GCF is, because 3 is the common factor for 3, 12, and 15. X is the common factor for x3, x squared, and x. So let's go back over to the polynomial here. And now we're going to actually factor out this 3x. So we're going to divide all 3 terms. Remember, it has to be able to divide out of all the terms. And we're going to divide out a 3x from all 3 of those terms. So 3x comes out front here because that is what we're dividing out. Whatever it is that we're dividing out has to be included in our answer. because we're trying to write the answer in factored form. And then I do the math. So 3 divided by 3 is 1. x3 divided by x is x squared. Remember, 3 minus 1 is 2. That's that exponent stuff from last unit. Negative 12 divided by 3 is negative 4. x2 divided by x is just an x. X squared divided by x is x. And then 5 divided by 3, 15 divided by 3 is 5. So that's a positive 5. X divided by x is just 1, so those x's go away. So here's my answer. 3x times 1x squared, or you could just put x squared. You don't have to put the 1 out front. Minus 4x plus 5. Now, it is critical here. I'll put this in blue, I guess, so we can see it, right? That 3x, you must include the GCF in your answer. Let's make a note about that. So you must include the GCF in your answer, right? And this is because so I'll scoot this over, right? So you must include the GCF in your answer, right? So because if you multiply the factored answer can't read my writing very well, I apologize. So if you multiply the factored answer, you get the original polynomial. I need to get my eye pencil fixed. Original. It's harder to write with my stylus. Polynomial. Right? So let's do that. I'll change it over here to red. I'm gonna go ahead and do that multiplying back out. So if you multiply the factored form back out, you're going to get the original. So if I take this 3x, right, 3x is what was out front, times x squared, or 1x squared, either way, minus 4x plus 5, right? That was the answer we got. And if we multiply it, right, 3x times x squared is 3x to the power of 3. And then I do 3x times negative 4x is negative 12x squared. Make that a negative. And then 3x times positive 5 is positive 15x, which is the original polynomial, right? So that's why you have to have that GCF out front, because its factored form is just the opposite of multiplying it back out. Okay? So make sure you don't forget that, because I hate when I take points off of students' work because they forget to put that in. It's super important. It's there. All right, so let's try another one. So we have 5v squared plus 10v to the power of 3. So I'm going to go over here to the right where I wrote down for us to do the math here. So we have 5. So our factors of 5 are just 1 and 5, right? That's it. Factors of 10 are 1 and 10 and 2 and 5. And that's it. And then this should be a v, not an x, right? The variable is v. So we have v to the power of 2, which is, right, v times v. And then we have v to the power of 3, which is v times v times v. Right, so those are everything factored out. So now let's take a look at my GCF. So I have a 1 here and a 1 here, and I have a 5 here and a 5 here. So the number is going to be 5, because 5 goes into 5, 5 goes into 10. You might have saw that right away. If you did, awesome. I don't expect you, again, to factor, right, all these factoring out if you see the GCF as 5. But I'm just helping. If you don't see the GCF as 5, then make the lists, because the lists work. And then we have v squared here, so I'm going to change over to blue. And so they have a v in common, and then they have another v in common, which means that they have a total of v squared. Right? So out of v squared and v to the power 3, v squared is what can be taken out of both of them. So going back over here to the right, now we can factor out our GCF. So I'm going to divide out of both of these terms 5v squared. So 5v squared comes out front. And then 5 divided by 5 is 1. V squared divided by v squared is 1. So that just is 1, right? Everything, the whole v squared, 5v squared divided by 5v squared is just the number 1. Don't forget that number 1. It doesn't go away. It's not 0. It's 1. And then 5 divided by 10 divided by 5 is 2. v3 divided by v squared is v. So 5v squared times 1 plus 2v. That is the factored form for that polynomial. All right, got a couple more here. So 3t squared minus 18. All right, so let's go over here to the right. Factors of 3, I have 1 times 3, that's it. 18, I have 1 times 18, I have 2 times 9, and I have 3 times 6. All right, and then my x's, or it's not an x this time, it's a t. I have t to the power 2, and then I also have none. The second one does not have any, right? I like to write the word none. If I'm going to list things out, I'm going to write the word none, just to remind myself that there isn't any there. And so let's look at my numbers here. I have 1 and 1, and I have 3 and 3. So my GCF is 3. If I look at my letters, I have t squared, and then I have none. If we have none in one of them, then we cannot divide out a t, right? So t is not in both terms, so not in GCF, right? Has to be in both terms to be in the GCF. So since the t is not in both terms, it's not part of the GCF, or not in the GCF. So the number 3 is it. That's all we have. So the GCF of 3t squared minus 18 is just the number 3. So I'm going to scroll this back over. Remember, anytime you can pause if you need to keep writing, do that. All right, so we're going to divide out of 3, and we're going to divide out of 3. So 3 comes out front. We're left with 1t squared, or just t squared if you prefer, minus 6. And that's it. Divided out a GCF of 3 this time. Okay. All right, I want you to go ahead and I want you to pause the video at this point, and I want you to see if you can find the 4x3 minus 2x squared minus 6x. Go ahead right now and calculate the GCF for this, and then divide it out and see if we can come up with the same factored form. All right, let's see. Welcome back. Let's go ahead and see if we got to the same place real quick. So let me do it. So 1 times 4, 2 times 2, 1 times 2, 1 times 6, 2 times 3. We have x to the 3, x squared, and we have just an x, right? So if I'm looking at here, I have 1, 1, 1, 2, 2, 2, so that's a 2. X is all they have, because if we do this, x times x, there's one of those. And if you wrote them out, then there's one of those. So 2x is my GCF. Hopefully you got a GCF of 2x. Let's divide that 2x out of all 3 of these terms. This is a cubic trinomial. If you remember, we were naming them last week. So we have 2x for 2x squared minus 1x, or just minus x, it's up to you, minus 3. Uh-oh, I forgot my parentheses on the end. Don't forget that. Right, because it's multiplication. So, right, so it's 2x times 2x squared minus 1x minus 3. So hopefully you got that as your answer. Now, down here, number 5, this one's a little bit more complicated because we got 2 variables. So let's just check and make sure we are good with doing 2 variables. So I'm going to scroll over here to the right. I have all my stuff lined up so we can do this math. All right, so 6, the factors of 6 are 1 times 6 and 2 times 3. Factors of 15 are 1 and 15 and 3 and 5. Factors of 18 are 1 and 18, 2 and 9, and 3 and 6, right? So these are my factors for the coefficients. My factors for the m's, looking here, I have m to the 7, I have m squared, and I have m to the 4. And then for my n's, I have n to the 3, I have n to the 4th, and I have n squared. Right, so those are my n's listed out. So let's look at my GCF for my numbers first. So we know they all have a 1. They do all have a 1. They do not all have a 2. But it looks like they all have a 3. So they all have a 3. They do not all have a 5, a 6. That's it. So my GCF number, the biggest number they have in common is 3. And then I look here at my n's. And when I start looking at my n's, I'm not going to write them out this time, right? We have 7, 4, and 2. So 2 has to be my m's. And then for the n's, I have 3, 4, and 2. Again, 2 is what they have in common. So when you're looking for the GCF of the variables, you kind of seems counterintuitive. You're looking for the smallest exponent number because that's what that biggest number they have in common. Biggest number they have in common is the smallest exponent because that's what can be divided out. So let's go ahead and take a look at dividing out 3m squared n squared from all of these guys. Make this just a little bit bigger, make it easier for me. Let's have it snap to it sideways, but fix that later. All right, so we're gonna divide out a 3m squared n squared out of all of these. Has to be the exact same thing we're dividing out of all three terms for this trinomial. All right, so the 3m squared n squared goes out front, and then 6 divided by 3 is 2. M to the 7th divided by m2. Remember, this is just simplifying with those exponent rules. That's why we did exponent rules last unit. So 7 minus 2 is 5, so that's m to the 5. n3 divided by n squared is just n. And then I look at the next one. 15 divided by 3 is a positive 5, so plus 5. M squared divided by m squared is 1, right? Those go away. And then n4 divided by n2 is n squared. So this one just has an n squared term. 5n squared is the middle term. And then negative 18 divided by 3 is a negative 6. Don't forget that minus sign. m4 divided by m2 is m squared. And then n2 divided by n2 is just 1, so that the n's went away in that one. So here's my final answer for my problem. 3m squared n squared times 2m5n plus 5n squared minus 6m. So it can be helpful to think of these as separate problems, right? Let's see, right? This is one polynomial to be simplified, and then here, term, and then here's another term to be simplified, and then here's a third term to be simplified. All right, so we're simplifying three little terms, and then don't forget to put that 3m squared out front once you're done with all that simplifying. All right, one last problem in our notes. We are almost done, I promise. All right, so 4h3 plus 9h minus 7. So I'm going to pull this over here so we can do the work over here. Right, so we have 1 times 4 and 2 times 2, 1 times 9 and 3 times 3, and 1 times 7. And then my variables, we have h to the power of 3, we have h, just one h, and then we have none. Right, there's no variables in the last term. So if I'm looking for my GCF here, they all have a 1 in common. That is all they have in common, right? So my number is number 1. Then look at my variables. They have h3, we have h, and we have none. If there are none, that means we cannot take an h out. So that means that my GCF is 1. What did we say back on page 11? No, page 10. Way back on page 10. Way back on page 10, right? The fact that they all have in common is 1. If they all have just a 1, then here, right? So the only factor is 1, is the number 1. If the only factor of anything is the number 1, then we are calling this a prime polynomial. It cannot be factored, right? So just like with numbers, polynomials may also be prime and cannot be factored. So if something cannot be factored, then we just write it as prime, right? So if we try to factor something and it does not work, then we write the answer as prime. All right, that was a lot, I know. I apologize. Take a deep breath. You'll get some practice on this on Wednesday in class.